Now today we will understand how to find out left hand and right hand limit. So we have a question. We have already discussed about the limit in my previous lecture. Today we will discuss the evaluation of limit. So evaluate the left hand and right hand limit of following function at x is equal to 2, where fx is equal to 2x plus 3 when x is less than 2, and x plus 5 if x is greater than 2. Clear? Okay, now we have to understand also, we have to prove that does limit exist. Clear? Okay, so solution, will see how we find that solution. First of all, we have to find left hand limit, so we can write it as LHL, left hand limit. For that, limit x tends to 2 negative fx. Clear? And we can write it as limit h tends to 0, and in place of h we can write it as f2 minus h. Clear? Limit x tends to 2 negative fx, limit h tends to 0, f2 minus h. Clear? आगे चलते हैं. Limit h tends to 0. Now in place of x we have 2 minus h, so we'll put up, first of all we'll select the function. So we are talking about 2 minus means if the value of x is less than 2, so we'll select this one. Okay, so 2 in place of x, what we have to put up? 2 minus h, 2 minus h and plus 3. Limit h tends to 0, 4 minus 2h plus 3. Clear? And finally we can write it as 7. Clear? Because h is very close to 0, so we can treat this negligible, so we have 7. Now RHL, right hand limit. In right hand limit we can write limit x tends to 2 plus fx. Clear? And this can be write as limit h tends to 0, f2 plus h. Okay, now put in place of select the function. So our value is greater than 2, so 2 से greater value के लिए कौन सा function है? x plus 5. So x plus 5 choose कीजिए. Limit h tends to 0, or the function we have 2 plus h plus 5. Again we can get this 7. So finally what we can write? Hence RHL is equal to HL. Clear? Now we go to next question. Okay, now we have a question. Find the value of limit x tends to 3 x square 2x minus 15 upon x minus 3. Clear? When x tends to 3, when x goes to closer to 3, then function goes on, put up the value 3 रखिए, 3 minus 3 0, 9 15 0. So function tends to 0 upon 0, means this is the condition of indeterminate. Indeterminates. Clear? So this is a problem. For that we can factorize first of all this limit x tends to 3 we can factorize this. So after factorization we can write it as x square plus 5x minus 3x minus 15 upon x minus 3. Limit x tends to 3, so we can write it as x plus 5 x minus 3 upon x minus 3. So it is cancel out. Now we have x tends to 3 x plus 5. So what we have to find? We have to find the value of function. So we can write it as hence limit x tends to 3 x plus 5. In place of x we have to put up 3. So now we get 8 answer. Clear? So we will solve two type of question. One question in which we have to find out the existence of limit. Another is to find the value of the given function. If you have given find the value of functions, you can put up directly in place of x is equal to 3. Clear? Now we have some special cases. Why we are talking about this? Because we are getting the condition of indeterminate. तो हमको कैसे पता चलेगा कि किस केस में हमको, first of all let us understand the indeterminate forms and then we will discuss about another things. Okay, now some standard result based on limits. So we have some standard results. First, limit x tends to a x to the power n minus a to the power n upon x minus a is equal to n a to the power n minus 1. Second, limit x to the power x tends to 0 sin x upon x is equal to 1. Third, limit x tends to 0 tan x upon x is equal to 1. Next is limit x tends to a sin inverse x upon x is equal to also 1. Then limit x tends to 0 tan inverse upon x upon 1. Limit x tends to 0 e to the power x minus 1 upon x is equal to 1. Limit x tends to 0 a to the power x minus 1 upon x is equal to log e base to a. Limit x tends to 0 log 1 plus x upon x is equal to 1. Clear? Next is limit x tends to 0 1 plus e to the power 1 upon x is equal to e. Limit x tends to infinity 1 upon 1 plus 1 upon x to the power x is equal to also e. Next is limit sin x upon x is equal to limit very carefully understand that x tends to infinity. Clear? So we have two different cases. When x tends to 0 sin x upon x is equal to 1. When limit x tends to infinity sin x upon x and cos x upon x is equal to what? 0. ठीक है, ध्यान से रखिए दो चीज़ें आप यहाँ पे मैं आपको बता रहा हूँ. द डिफरेंस इज द लिमिट टेंड्स टू. क्लियर है? तो ये सारी चीज़ें यहाँ पे भी आप किसी में भी वैल्यू पुटअप करेंगे तो आपको क्या मिलेगा? इनडिटर्मिनेट्स वैल्यू मिलेंगी. सपोज दैट ए रखिए यहाँ पे एक्स की प्लेस पे, सो 0/0. यहाँ पे भी 0/0 0/0. So this is some special case that you have to remember, memorize this. Clear? So pause the video to note down.